Hi, welcome to worksheet number 12, maximum minimum values. Here this corresponds to book section 3.1, maximum minimum values. So maximum just means, I see maximum minimum. Maximum means the highest value, and minimum is the lowest value. So it kind of translates to, if we look at the graph, max will be the highest point of the graph, and the min will be the lowest point of the graph. And this worksheet will investigate different ways to determine whether the graph has extreme values. Like in this chapter, you'll see a lot of math concept that we learned so far, and then we're going to try to tie that to the graph, so we'll investigate graph in more detail. All right, let's look at the first definition. Function with the domain D. Domain just means where the function is defined as absolute or global max at C. If so, here I'm going to just clarify that this is x value where x is equal to c. If f of c is bigger than or equal to f of x. So maximum again means it's the biggest value. That means the value at c is bigger than any other values, right? So f of c is bigger than or equal to f of x for all x in the domain D. F of c is called the maximum value of f on D, right? So f of c is called maximum value. That's the height. See, f of c is the y value, which is the height of the graph. So the y value is called the maximum, and it happens at x equals to c, if you have an absolute maximum. I'll more likely to refer as a global maximum. Absolute max or global max, they're the same thing. Global means like the world. So this is the maximum value of the world, right? Function with the domain D has an absolute minimum or global minimum. If f of c is less than or equal to, again, this is the smallest value or the lowest point of the graph. F of c is called the minimum value of f. Note, max and min refers to y value, right? When it comes to the graph, every point on the graph has x value and a y value. So if we talk about the minimum and maximum, we're actually referring to the y value of the point. On a graph, is the y value the highest and the lowest point, right? If the global max of f of x is 10 at 3, so this is kind of like what I'm going to say, how I'm going to say it, that means 3 is the x value and 10 is the y value. So I'm going to say max is 10, it happens at 3. So at 3 means when x is equal to 3, right? So another way of saying is f of 3 is equal to 10. So 10 is the y value, so which is the max. If this was max, and it happens at 3, right? All right. And then another note I want to say, another comment I want to say is that global min and max could possibly be the endpoints. So for example, like I have a graph like this. If like this point happened to be like higher, that'll be the highest point of the graph. So that could be global max. In a sense, it's the highest point of the graph. Like the way it's given is not the highest point, so I'm going to say that. But in case this was like over here, right, then I can say the endpoint is whatever value that is the global max. Right, example 1, I have a graph like this with different points. It says, what is the maximum value of f on this domain? So graph goes like this. What is the highest point of the graph? Q, right? So it doesn't give me like the y value, so I had to kind of make it up. So maybe 1, 2, 3, 4, 5, 6, maybe 6, right? So 6 is the maximum value of f on this graph, right? And the min, again, kind of same thing, is the lowest point of the graph, like here, r, right? So that's, again, I don't have the values, so I'll make it up, -1, -2, -3, -4, maybe -5, so -5. And this happens at point Q, this happens at point R. But if they ask you to find the max or min, is 6 and then -5. Later I'll talk about like, how about P? Well, it's not the lowest because R is the lower than P. But like if you kind of look at this, you can kind of see P is the lowest around like here, right? So we'll give like different name for those kind of stuff. Like Q, like look at S. It's not the highest point of the whole graph, but it's highest point like in this region, right? So we'll kind of talk about that in a bit. Actually, that's the next topic. A function has a local or relative maximum. So local means like just around u, right? If f of c is bigger than or equal to f of x for all x near x. And then same for local min. it's the smallest value around you or near you, right? Near C. All right. And here, this is technicality. Local max and local max or local min cannot be the endpoint. So it has to, like, this cannot be local min, this cannot be local max. It has to be like the function has to define around it. That means it has to have something to the left and something to the right. So that's for technicality. So I think the next question is asking for to find the local max and local min. So in this case, like P, this is the lowest point, not out of the entire graph, but out of only like this part of the graph. So that's what local means. If you just kind of look at your neighborhood, you're the lowest point. So I can say local, in the given example, local min happens at what point? So like this, it happens at P. It also happens at R. And then what else? And it also happens at T. Right? So those are 3 lowest point around its neighborhood, right? So if you're P, if you just look around you, you're the lowest point. If you're R, if you look around you, you're the lowest point. You're T, if you look around you, you're the lowest point. Let's say you're Q, you're not the lowest point, right? Or if you're like random point here, you're not the lowest point around you because one side is higher than you, the other side is lower than you, so you're not the lowest point. So local min happens at these 3 points. And I can kind of also say local max, let me move up a little bit. Local max happens at, so local max is highest point around you. So Q, if you look around, you're the highest point around you. S, if you look around only this part, you're the highest point, right? So Q and S. Q and S, all right? I was basically asking example 2. All right, let's look at the next example here, or next theorem here. Extreme value theorem, EVTE. Let's say f is continuous. Again, continuous means in terms of graph, I should be able to draw the graph without like lifting a pen, right? That means it doesn't have a, so continuous means no gap, or there's a hole, there's no jump, everything is connected, right? So if you have a continuous function on A and B, right? F is always, then what it says is f of x always attain absolute min and absolute max, right? On the interval AB, again, this is technical, it's very important. This is closed interval, so that means you include endpoints. So this means A and B are both included in your domain. In your domain, right? So that's the closed interval. Okay. So my comment is if f of x is not continuous, means if it has a gap or hole or jump, then it may not attain its absolute value or mean in the interval AB. So I'm going to draw 2 examples. Let's say AB is like 0 to 4. I just made it up, okay? That's my A, that's my B. If it's, the first example is I have a continuous function. So again, I'm going to just make it up. Let's say I'll start here. 4, I'm going to end up here. Because it's continuous function, whatever graph I draw, I have to draw it like they have to connect it, no gap, hole, or jump. So maybe something like this. I don't know, I just made it up. Okay. So if that's the case, then it says if it's continuous, it always have to have absolute max and absolute mean, or global max and global mean. Here, let me say global. So for example, where is the lowest point? Like this is the lowest point. So this is global max. I mean global min, maybe like negative 0.8 or something like that. Global max, what's the highest point of the graph, like entire graph? Right here maybe. So that may be like 3.5 or something like that. So that's global max, and that's global min. So if it's continuous function, there should be always 1 if you have a closed interval 0 to 4. I'm going to look at the case where it's not continuous. Not continuous. So I'm going from 0 to 4. So what if you have a graph something like this? A point here goes like this. I'm just going to make things up. It goes up to the negative infinity, goes to the positive infinity, and 4, my function is defined to be this and this, right? So not continuous because I have to start here, jump, draw the graph, goes up forever, lift the pen, and then I have to draw this point. So my function is defined on 0 to 4 again. So that part is the same. That's A, that's B. However, where is global max? Where is the highest point? Well, it keeps going up and up and up. So there is no one point because whatever point you pick is the highest, it goes past that. So there is no highest point. Same for the min. Is there a minimum? Like it goes down, so there is no minimum. So this one doesn't have global max. It doesn't have global min. So I'm going to write that here. No global max nor min, right? Because this was not continuous, it's possible. If it's continuous, you have to have those 2 points. Okay, so that's a theorem. If it's a continuous function, you have to have a max and min on the closed interval. All right, let's look at the next theorem. Next theorem says it's the Fermat's theorem. Fermat is name of a French mathematician. It's pretty famous. It's pronounced Fermat. You don't pronounce T because it's French. You can just say Fermat. It's fine. f of x has a local min or local max at a point C, and also the derivative of C. See the derivative exists, right? Again, in terms of graph, derivative is the slope of the tangent line. So let's say there's a max, local max to local min, and then it happened to have a derivative at that point. Then the derivative has to be equal to 0. F prime of C is equal to 0. Okay. So what it says is, if you have local max or min, and if the derivative happened to exist at that point, then it has to be 0. So what does that mean graphically? Again, like on this section, I'm gonna like always refer to graph, just so that I want you to make sure you see the connection between the graph and algebra or derivative. If f(x) is differentiable, that means there's a derivative, right? And has a local max and min at x is equal to c, then graph has to have a horizontal tangent line, right? The reason is that horizontal tangent line means the slope is equal to 0. That means f prime of c is equal to 0. Because again, the derivative at a point represents the slope of the tangent line. Well, it says the slope, the derivative is equal to 0. That means, in terms of graph, the slope is 0. That means it's the horizontal tangent line. Horizontal line looks like this, right? If you have a other side note, if you have a vertical line, then derivative doesn't exist because the vertical line doesn't have a slope. Okay, so let's look at the example. Like, let's look at the case where it applies, and let's look at the case where it doesn't apply. So it says f of x has local min and max. So let's just draw a random graph like this. Goes like this. So local max, again, it doesn't have to be highest point on the graph ever. It has to be highest point on the graph, like around itself. So maybe this is local max. And this is local min. And in terms of graph, when the derivative exists, it means it's not a sharp edge. It's a smooth like that. So what that means is, if you look at the tangent line is like horizontal. You can kind of see that. Tangent line is horizontal. So it's not like here. This is not when you have a local max or min. This is not local max or local min. And you can kind of see tangent line goes like that. That's not a horizontal tangent line, right? This is horizontal tangent line, and that's happened to be the highest point around it. This is the horizontal tangent line, and that has to be the lowest point. So this is where you have the derivative, right? When does it not apply? When derivative doesn't exist at a certain point. Again, like if I have a graph like this, local mean here, right? But then derivative doesn't exist. But f of 1 does not exist because it's not differentiable there, right? It's a sharp edge, so does f prime of 1 doesn't exist. Like here, I think I forgot to say, f prime of like 1.2 is equal to 0. Like f prime of negative 1.2, something like that, is also equal to 0, right? All right. And let's look at a little bit more with those kind of stuff. Number C is called a critical number, which is kind of important for terminologies. We're going to refer to critical number like a bunch of times later. For f, if f prime of C is equal to 0, or f prime C doesn't exist, right? So again, I want to translate that into graph. Like, what does that mean on the graph? Graphically, it has a horizontal tangent line. That's when your prime is equal to 0. And f prime of C doesn't exist. That's when you have a sharp edge. Or if function is not continuous, then the derivative doesn't exist, right? So sharp edge or not continuous, mostly sharp edge. So either it has horizontal tangent line or it's a sharp edge. All right, so incorporating like what we learned so far to find the absolute extreme value. Extreme value just means global min or global max. So if absolute extreme just means global min or global max. Of continuous function on a, b. So let's say you're given a continuous function, and how do you find, like algebraically, the highest point and the lowest point of the graph? First, you find the critical number. Okay, the critical number is like you take the derivative, set it equal to 0, find to see where the derivative becomes 0. Or sometimes your function doesn't have a derivative at some point, right? That means basically zero denominator. When you have zero denominator, then things are undefined, right? So either derivative is equal to 0 or derivative doesn't exist, or zero denominator as a fraction. So that's the first part. And then the value at the endpoints, because sometimes the global max and min happens at the endpoint, right? So if it doesn't have at the endpoint, then is one of the critical number, or you could possibly have an endpoint, and then compare the values and see which is the biggest and which is the smallest. All right, let's look at example 4. Find the extreme values, global min and global max of this function on 0, 1. All right, so first of all, I notice this is continuous. I'm going to write this continuous. So I know that there is a global max and global min. That means I know there's a highest point and then there's no lowest point on this graph, on this interval 0, 1. This is my A, this is my B, right? So how do I do that? First step was to find the critical numbers, right? Meaning the derivative. I want to look at the derivative and see if it's equal to 0, right? So that's like when graph goes either like this, so that's the highest point, or graph goes like this, so that's like the lowest point, right? So let's look at that. So I'm going to take the derivative. So to find critical numbers, f prime of x, I'm going to set it equal to 0, right? So what I'll get is f prime of x, I'll take the derivative, 3x squared plus 2x minus 1. I'm going to set that equal to 0. This is a quadratic equation because I have x squared something something. So easiest way is to try to factor. So how can I factor this? Again, like you have to kind of refresh your factoring skill. 3, 1, 1, 1. That's negative. So 3x minus 1, x plus 1. For factoring, you can always double check your answer. So kind of FOIL it out. 3x times x is 3x squared. 3x times 1 is 3x. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. So that's 3x squared plus 3x minus x is plus 2x minus 1. That's what I started with. So I know this is correct factoring. Especially on the exam and stuff, I know I've seen people just factoring wrong all the time. Then you get completely wrong answer. So that's very unfortunate. So on the exam and quizzes and stuff, take your time factoring it, double check your answer, make sure, otherwise everything is going to be wrong, right? So I got that. Sidetrack a little bit. So that means, so I have something times something is equal to 0. That means either first thing is equal to 0 or the second thing is equal to 0. Let me scroll up, so I need more space here. Okay. So then what I get is 3x minus 1 is equal to 0, or x plus 1 is equal to 0. So x is equal to 1/3, or x is equal to -1. Here, our domain is just between 0 and 1. So 1/3 is here. So that's one of the critical number. This doesn't belong here, so I don't have to worry about that. So here, not in the domain. So I'm not going to worry about that. So that's my critical number. Is there where the derivative doesn't exist? This is polynomial, so x. This is true for all x. But if your derivative was like 1 over x or something, then x is equal to 0, where the derivative is not defined, right? So in this case, derivative is defined everywhere. So that's my critical number. 2, I have to find the endpoints. Because here they're like saying, I find the critical number. Second, you find the values at the endpoint. So check the endpoint. That means f of 0 and f of 1. Right? And then compare that. So f of 0 is just means. So these parts is a little easier. You just plug it into the original equation. I want to see how high the graph goes. So when x is equal to 0, just plug it in, 0 plus 0, 0, 0. That's just a 0, right? And then plug in the endpoint 1. And then that means plug in 1 here. 1 plus 1 minus 1, so that's 1. So that's 1. Another point, and then so those are the endpoints, and I also need to check the critical number. So f of 1/3. So I'm going to plug that into the original equation. So that will be 1/3 cubed plus 1/3 squared minus 1/3. So that's 1/3 cubed is 1 over 27 plus 1/3 squared is 1 over 9 minus 1/3. 27 is the common denominator. 1 plus, I need 3. So that's 3 plus minus, I need 9. So minus 9. So negative, it is 4 minus 9, -5 over 27. Okay. All right, so there's a lot of information. We did a lot of stuff. So like, what does that do? I check the endpoint and I check the critical number. So I have to kind of compare this, and this, basically. So when I plug in 0 for x, I get 0 for y. So I know 1.00 right here. So this gives you 0, 0. When I plug in, for next point, when I plug in 1, I get 1 also. Okay, that's 1, 1. Where's that 1, 1 is right here. The other point I get is when I plug it in -3, I get that. So that means from here I get -1/3 and -5 over 27. So 1/3 is somewhere like here, and then -5 over 27 is about -1.85. I calculated it off, so your point is like here. So your graph goes like starts from here, it goes like somewhere there, and it goes up like this. So I don't know exactly how a graph looks, but my guess is it's going to look like this, right? All right. So here I can say, well, this is the lowest point because this -5 over 27, 0, 1. So I have to compare 3 numbers, 0, 1, -5 over 27. Well, clearly this is the smallest number and this is the largest number. So I can say this is the min and this is the max. So my final answer is, after all this, global min is -5 over 27, and then global max is equal to 1. So that's my final answer for this. All right. All right. Example 5. This one, derivative is slightly, so same thing. Find the extreme values of this, right? So we'll kind of do the same process. Let me kind of do the setup and find the critical numbers. Find the critical numbers to find, now compare the endpoints. That means f of -3 is something, f of 3 is something, and then f of c. So I don't know how many critical values you're going to get, but we're going to get a bunch of c's. That's from the critical number, which means either your derivative is equal to 0 or derivative doesn't exist, right? So plug those numbers in, you get a bunch of answers, compare all the y values, and whatever is the smallest will be your minimum, global min, and whatever is the largest will be your global max. So here I'm going to have you try this one, and basically that's it for this worksheet. If you need a little hint or try it, the derivatives, you can just doable. You have to use product rule, because here I have x times radical, and derivative becomes a little bit complicated, and it also has a point where the derivative doesn't exist. So if you calculate it out correctly, f prime should be radical 9 minus x squared minus x squared times 1 over radical 9 minus x squared. Again, you have to set it equal to 0. How to do that? Well, I have this like a fraction, I have a denominator. That means we have to have a common denominator, because it's like this minus that. So again, this is kind of like a lot of algebra. So I'll just have to multiply this on top and bottom for this guy, so I can have this as the denominator. So what I'll do is I'll multiply here 9 minus x squared over 9 minus x squared. So if you do that, that's like radical 9 minus x squared that I had originally, and then 9 minus x squared that I multiplied over 9 minus x squared minus x squared over radical 9 minus x squared. So once I have it, I have a common denominator. This becomes nice because it's radical this times that, so just radical will go away. And again, here I'll make a comment, f prime of x doesn't exist when the denominator is equal to 0, right? Radical 9 minus x squared is equal to 0. That means 9 minus x squared is equal to 0, right? When this number becomes 0, then it's radical 0 becomes 0. Then f prime of x doesn't exist. So here, I need to find, so what is that? What am I trying to say? We need to find when f prime of x is equal to 0, and also when f prime of x does not exist. So when is it 0, I have to look at the top. When is the top 0, that's when your derivative is equal to 0. When the bottom is equal to 0, then when the derivative doesn't exist, right? So this one you have to do like a lot more stuff. If you calculate it correctly, your critical value is x is plus minus radical 9 over 2. This is when the derivative is equal to 0, and then plus minus 3. Then that's when your derivative doesn't exist. So eventually what you have to do is you have to plug in those numbers into f. So you have to find f of -3 as one of the endpoint. You have to find f of 3 as one of the endpoints. And then you have to check f of radical 9 over 2. You have to check f of negative radical 9 over 2. You have to check f of 3 and f of -3. So there are a bunch of numbers you have to check. So out of all these numbers, whatever is the highest will be your max. Whatever is lowest, it'll be your global min. All right. So your final answer is global max is 9 over 2, and global min is -9 over 2.